All right, in 8.2 here in geometry, we're going to find the lateral area, the surface area, and the volume of prisms and cylinders. And instead of doing it with nets, there's formulas for it, right? So at the top of your paper here, you can see all these different formulas for for lateral area, that's not a highlighter, but for lateral area, for surface area, and for volume, based on if you have a prism or a cylinder. So let's just kind of dive in and see. First is shape recognition. Is we've got ourselves a prism on here. It's true that it is a box, right? So we have our yellow card that's got some formulas on it, and I've also modified these a little bit to like be a little more specific for some of their base areas. But let's start with the lateral area, and we'll show all this work. Let's keep ourselves nice and organized. I know you're going to hate it, but we're going to write these formulas down first. So lateral area of a perimeter, of a prism is perimeter of the base times the height. Like, I'm not a big fan of saying pH. I'm happy that you know that, but we'll call P perimeter of the base and H the height. So we'll just kind of bring these guys down. Perimeter of the base, we'll grab a calculator and we'll just add this up. It's 15 plus 8 plus 15 plus 8, right? So if we add all that up, got her all snazzily punched in. I got 46 for the perimeter of the base. And then the height of this bad boy, if we go right here, the height of that prism is 10, right? So we'll write that down. So I wanted to see, you write the formula down, and then you did the perimeter of the base. You could do that in your calculator, and then the height. Then we just kind of punch that in. And notice I keep bringing LA equals down, so that would be 460. And then the label on that would be centimeters squared. Everything that's an area will be in square units. Then if you notice the surface area, is all we got to do is add two base areas to it. So for a prism, we have the lateral area plus two base areas. So I'm going to go somewhere else. If you're going to go down further, great. Leave a space to where your work isn't all flowing together. Or I could go off to the side. Surface area equals a lateral area plus two base areas. Notice he's a capital B, not a lowercase b. They mean different things. Lowercase b means base. Capital B means base area. So cool thing is we got the lateral area figured out. It was 460. And then two base areas, you can do that in your calculator. The base is just a rectangle 8 times 15, so we'll figure that out. And like for a rectangle, I don't need you to show me any work. He is just 120. But I do think it's a good idea to put 2 times 120 in your formula, because when we get to pyramids and cones, they only have one base, and these have two bases. So now we'll go back and do 460 plus 2 times 120, and that will be my entire surface area. Everything we did with the nets, we found the lateral area. They were all rectangles, so you could just do the giant perimeter of the base times the height, and then you had to add those two base areas to do that. So 700 centimeters squared. So that's just like surface area. That's like what it would take to wrap this thing in paper, or it's all of the space around it. The volume is the space inside. And if you look to your yellow card, yes, this is a prism, but he is also a box. You've known this formula for volume of a box for a long, 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 long time. It's the length times the width times the height. And the truth of the matter is it doesn't matter which one is actually the length and the width. You know, we've already defined the height to be this, so we're just going to punch that straight in, 15 times 8 times 10. Like, I don't want to overcomplicate anything when it comes to volume of a box, bro. It's just length times width times height, which is 1,200. But what does change? It's centimeters cubed. And that's what it would take to fill this guy up with, say, like water or sand or any kind of object. There's 1,200 cubic centimeters of space inside of that thing. That's, known as the volume. So here, a little different, right? So this is a triangular prism. So we'll still start. The formula for lateral area is perimeter of the base times the height. And it looks kind of tricky that they only give us these two sides. But look down yonder. They have a 20 right there. So I also have a 20 up here, because remember, the bases of a prism are congruent. So if I add those up, that would be the perimeter of the base, 20 plus 21 plus 29. The perimeter of the base is 70. So lateral area is going to equal 70 times the height of this prism. That would be this green machine right here of 30. And you could punch that dude in, get yourself a nice 2100 is the lateral area of this guy, and we'll throw our label of inches squared. All area is in square units. But then, my friends, the surface area, same formula. You could look above. It's your lateral area plus 2 base areas, because we have found all of the lateral areas. Got to add those 2 base areas. But for a triangle, I need you to go off to the side and show me some work. So here's one thing. Instead of doing A equals 1/2 base times height, which is true, it is the area, I'm going to change it instead of a capital A to be a capital B, because it's for the base area. So when it comes to this triangle, even if you like sketched him like kind of up and down so you could see him better, if you see he looks like this, don't you totally have a base of 20 and a height of 21 on that triangle? You got to be very careful, and when they mention the height, you don't need the height of the prism, which is 30. You need the height of the triangle up there, which could be either 20 or 21. It doesn't really matter which one's which. So 1/2 times 20 times 21, and you could punch that in and get 210 back for that base area. So if I go underneath here and sub this in, it would be the lateral area of 2100 plus 2 times that base area of 210. So we'll punch that in. 2100 plus 2 times 120. And I got 23, I did that wrong. It's supposed to be 210, so sorry about that. 2100 plus 2 times 210. That would be better, right? So how about 2520 for the surface area? There we go. Put that in. Surface area equals 20. I don't need the SA equals. Sorry about that, guys. 2520 inches squared. And then the volume, like this is the first weird one you've probably done in your life. You don't get to do length times width times height because he's not a box. The volume of this will be the base area times the height. If you go back to the formula sheet either on your yellow card or on the top of this page, capital B times H, baby. And what's nice about it is, although these problems are pretty lame, don't you fear, they'll get more interesting as the chapter goes along. We have all this figured out already. The base area is 210, and then the height, don't know why I wrote an equal sign there, but the height, we're trying to find the volume of the prism, so we need the height of the prism, which is 30. So we multiply those together. 210 times 30, baby. And I got 6,300 is the volume. So 6,300 inches cubed. All volume is in cubic units. It is the amount of space inside of this guy. If we was to fill him up with water or whatever, right, there's 6,300 cubic inches of space in there. Here's our next shape. Ooh, he is fancy. He is definitely a prism. But this guy, since the length, the width, and the height are all the same, he is known as a cube, right? Probably the most popular 3D object out there. You could use the same formulas we have been doing if you'd like to, but if you go to the yellow card under the cube section, there is a formula for lateral area that is 4s squared, because it's just S stands for the side length, and the side length is 5. So if you wanted to sub in, you could do 4 times 5 squared. And you got to be careful with this order of operations. You can't take the 4 times the 5 first. You have to do the 5 squared, right? Order of operations says that's going to be 4 times 25, which is 100. And since there's no label, we will do units squared on this guy. So surface area, you could do lateral area plus 2 base areas. It totally works, but for a cube, the surface area has its own formula. It is 6s squared, because all of the sides are squares, right? They're all 5 by 5, and there are 6 of them. So if you want to use the shortcuts, you can. If you want to use the long formula, it's all great. So surface area will equal 6 times 25. And we punch that in and get 150 units squared. And then the volume, you could do length times width times height. It all works. It'd be 5 times 5 times 5. And the shortcut is it's the side length cubed, right? Length times width times height, 5 times 5 times 5, S times S times S. So volume equals 5 cubed. And if you wanted to punch that in, there's caret key, which is right above your division symbol, raises it to a power. And to me, that's faster than doing 5 times 5 times 5, but either way works. I got 125 units cubed back for that dude. So pretty quick ones, just some special shapes. And then finally, the cylinder, where there's going to be some pies involved. If we go back to the top of the page, you can see the specific formulas for a cylinder. I went and magically snipped them out real quick. So lateral area of a cylinder is right here, 2 pi r times h, right? So we'll write that down. Lateral area equals 2 pi r times h. So here we go, baby. We will just sub in. A lateral area will equal 2 times pi times the radius. You know, I think we're smart enough to maybe take this radius times 2 right away. So like 9 times 2 is 18. And then there'll still be a pi with it. And then the height of that cylinder is 20, right? So I got times 20. I mean, you could write 2 times pi times 9 times 20 as well. It's not going to hurt my feelings. But one way or another, I want to see that you kind of figured all that out. Then we'll keep the pi with it. We got to do 18 times 20. Remember, we're not adding those together. We're multiplying. So the lateral area is 320 pi. But what we'll do is, I didn't make big enough answer blanks here. Sorry about that. We'll put both the 320 pi, and then we will also approximate it, 320 times pi, and round it to 1 decimal place to get about 1005.3. 1005.3, and they gave us feet, so we'll do square feet on that bad boy. Right, so we'll put the exact answer, boom, the one with the pi in it, and the approximate answer. Then when it comes to the surface area, you see that the surface area formula, if I could ever grab the right thing with my stylus, the surface area is still the same as before. It's the lateral area plus 2 base areas. So surface area equals lateral area plus 2 base areas. And the surface area will equal, we're going to use the exact number. Like, we never want to use an approximate until we're all finished. So we're going to go back to this 320 pi. And it's actually going to be pretty slick when we do it this way. Plus 2 base areas. Go off to the side. Base area is going to be pi r squared. So my base area is, I got to square the 9, and I hope that we kind of know that that's 81. So it's 81 pi. But I need 2 of those bad boys. So right there, I'm going to go ahead and now figure that out. 2 times 81 is 162. So this is actually 162 pi plus 320 pi, and that's why that's pretty cool, is because those are like terms and you can add them together. So 162 plus 320 is 482. So that means like 162 pi plus 320 pi is 482 pi. 482 pi in that case. So we'll put that into blank, 482 pi, and then we will also approximate him. 482 pi is about 1514.2, about 1514.2 square feet. And then lastly, for the volume, it is base area times height. Volume equals base area times height. And the cool thing is, yes, you can do pi r squared if you wanted to, but we already have the base area figured out, so I like this formula better. It's going to be 81 pi times the height of 20. So multiplying all this together, the pi is just going to come along for the ride. 81 times 20, bada boom, 1620, but don't forget there is a pi with it. 1620 pi. And then that's about, when we punch that in, so times pi, big dog, 5089.4 square feet. So all that is pretty lame, finding the lateral area, surface area, and volume. Here's what I like, is some realistic questions. So we'll do a lot of this chapter, and that's pretty much what our test is going to be about. So we got to do a little bit of crawling, of finding these lateral area, surface area, volumes. with lame questions before we do some realistic stuff is, a farmer owns a cylindrical tank exactly like this one in question 4. Thank you. Don't have to do any more math about that. It is open on the top. Ooh, and the bottom is on the ground, right? So only the lateral surface will be painted. Cool. We're going to paint this bad boy. How many gallons of paint will it be needed to do 2 coats? So I'm going to go back, and I need my lateral area, and what we're going to do is I'm going to steal the exact answer of 320 pi. So the lateral area, if I use a pen, lateral area is 320 pi, and it's in square feet. It says, how much will it cost to do 2 coats? Every gallon of paint costs 350, or not cost, but covers 350 square feet. So if you didn't know what to do with that 350, here's what you can totally do to make sure you know what to do with the number, is you can set up a proportion. 1 gallon of paint is to 350 square feet, and then that will be proportional to gallons over square feet as well, taking it way back. What we know is we know our square feet that we're going to paint is 320 pi. And I don't know how many gallons of paint that's going to be. So I can cross multiply with these bad boys, and I would get 320 pi equals 350 times x, and then end up solving for x by dividing by 350. And if you already knew that you just needed to take this number divided by 350, that's great. Not going to make you set up a proportion, but a lot of people don't know, should I multiply by the 350 or should I divide by the 350? Now it just showed me that I need to divide. So here's what I think would be safe. Figure out this 320 pi first and hit equals, and then divide it by 350. And it would take about 2.9 gallons of paint to do 1 coat. So x is this guy right here. But here's the crazy thing. I'm going to round it off for this. X is about 2.9, but honestly, I don't really want to round it off. It is true that you can't go to the store and buy a fractional amount of gallons of paint, like you can't go buy 2.9 gallons of paint. So, but the thing is I have to do 2 coats, so I have to take this number that's in my calculator times 2. And I like to not round it off ahead of time just because. So this guy is about 5.7 gallons of paint, so I'm going to do 2x equals about 5.7 gallons. But now is the part where we got to use our math, real world common sense, is how many gallons of paint do I need to buy? It doesn't even matter about math rules of rounding. We're always going to have to round that up to like the nearest gallon, so this would be 6 gallons of paint. Even if that was like 5.4 gallons, like 5 gallons is not enough. We have to round up every time in the real world. So we need 6 gallons of paint. And was that the question? Is that all they asked? Yes, it was. So 6 gallons of paint. Then the last thing that we got here today is this problem about a gift box. Oh my goodness, will you see this problem over and over and over again? They ask us to draw it also. So let's use shape 22 to like draw the bottom. So here's how I like to do that. I switch this from dash to solid. We'll draw these 2 sides like solid, and then the other 2 sides dashed. So we're drawing a box. This is shape 22, by the way. That's like the bottom base. And then to draw the top base, we'll do that on top, but all solid. And then you connect your lateral edges up and down. And you'll see that having a picture of this guy will be a lot more beneficial for a reason. Is what do they want us to find? Lateral area, surface area, volume. Well, let's read the question and see what happens. By the way, the box is 20 inches by 18 inches by 8 inches. So I just put those in. And notice I also put the labels of this guy because we're going to have to maybe do some converting. So what do I want to find? She's going to wrap the box with decorative paper for Rick's birthday. So out of lateral area, surface area, or volume, we have to figure out what we need. I think if we're going to wrap the whole box, we need the surface area. But I think maybe you guys have seen a present been wrapped before, like just having barely enough paper to do it. You need a little extra, right, to do all those fancy folds and overlaps. So we'll figure out this additional 15% of paper here in a minute. Can she do it with 10, oh no, square feet of wrapping paper? Well, holy cow, let's do one thing at a time. Let's just find the surface area of this guy. And even though this dude's in inches, we're going to just follow the lead here. I'm going to find the surface area of this guy in square inches. So before I can find surface area, I need lateral area. That would be the perimeter of the base times the height. So adding this up, 20 plus 18 plus 20 plus 18. And I got the perimeter of the base to be 76. And the height of that guy is 8. So 76 times 8 is 608 square inches. So she's in square inches, right? But we also have to wrap the two base areas, right? So I need to get my surface area is lateral area plus 2 base areas. Surface area will be 608 plus 2 times. The base is just a rectangle. I don't need any work shown on that. Just do 20 times 18. And I got 360, but it's got to be there twice, right? Because you got the 2 different bases. So 608 plus 2 times 360, and I got 1328 inches squared. So I know that she's got in square feet of wrapping paper. We're going to deal with that later, but there is 1328 square inches of this box that needs to be wrapped. But see, she's going to take this times an additional 15%. So here's the fast way to do it. You will need all of this plus another 15%. So we need to take 1328 times 1.15. Because if you change 15% to a decimal, it is 0.15. But she also has the entire box for another 100% of that material. So trust me on this, 1328 times 1.15. She is going to wrap. We'll just go ahead and round that up to 1528 square inches. So she's got about 1528 square inches to be wrapped. But the problem is that the little paper measurement is in square feet. And I'll bet you everybody in here knows that there are 12 inches in a foot. The unfortunate thing is we're not talking about inches and feet. We're talking about square inches and square feet. So here's a quick little demonstration. What if I called this square right here 1 foot by 1 foot? How do you feel that the area of that is 1 times 1, which is 1 square foot? And if I change the dimensions into inches, this is 12 inches by 12 inches. And 12 times 12, last I checked, is 144 square inches. So inside of 1 square foot, there is 144 square inches. So what I need to do is divide this guy by 144 to see how many square feet that would be. So we'll take 1528 divided by 144. And it's about 10.6 square feet. So about 10.6 square feet. And the question is, does she have enough paper? So the answer is no. She will need 10.6 square feet of paper to wrap the box, and she has 10 square feet of paper. So she didn't have enough. If she did, you would say yes to it, and then just fill in the same blanks in those situations. But the old square inches to square feet, because it's not just inches feet, it's in square, so it's 2-dimensional, 12 times 12. Holy cow, let us know if you have any questions on this bad boy, because we will help you. But let us know. Have a good one.